Who's my favorite student? I am. No. It's good old Anne. All right. I said make sure that you defic for full marks. What I mean by that is if you get the right answer, I will give you 2 out of 2. If you get the wrong answer and you show no work, you get 0. If you get the wrong answer but you use my defic approach, I'll give you part marks. An electric motor draws 48 volts. It has a resistance. How much current? Okay, this wants me to find that. They told me this. They told me that. I'm looking for an equation that has those in it with the I by itself. What is 48 divided by 15? I should be able to do that in my head. Divide by 3, divide by 3. It's going to be 16 over 5. 2.8? Am I right? No? Yeah? No answer. I wonder how many people have done the quiz. 3.2. Wow, I'm way off. 3.2. 3.2 what? Amps. If you got 3.2 and you got to have the units, amps, I'll give you 2 out of 2. Otherwise, I would give you 1 mark if I saw the equation, half mark for the numbers, half mark for the answer, and if you forgot the units, I take a half mark off. Those are 0.5s in my messy writing if you're trying to read that. About 5 years ago, I was teaching Math 12, and I always put these little part marks on my answer keys to remind myself how to give out part marks. And I had a kid cheat on my Math 12 test. And the reason I knew he cheated, because he'd stolen an answer key, one of mine. And the reason I knew he'd stolen the answer key was because in his answers, he'd also written these 1s with circles and these 0.5s with circles, because he thought those were part of the answers. He had no idea what he was doing. So he'd actually written my marking scheme in his answer key. And he'd also inadvertently flipped 2 pages. So he had all of the answers on one page perfectly for this page, and all the answers perfectly for this page on the other page. So anyways, good news is he was bad at cheating. Number 2 wants me to find power. They told me I'm looking for an equation that has power, current, and resistance, and it has the P by itself. I think I gave you this one, yes? I squared R? I had somebody email Mr. Dueck, how do I do squared? Well, what does squared mean? To put the power of 2 or times itself. So if you got a calculator that doesn't have a scientific notation, you would go 8 times 8 times 4. If you have a calculator with scientific notation, you can go 8 squared times 4. It's going to be 64 times 4, 256? Is that right? 256 watt. Ah. Same deal. 1 mark, half mark, half mark off for the units if you missed that. But if you got it the right answer, Hudson, 2 out of 2. Number 3. Number 3 was already a curveball. They gave me power, except what units did they give me power in? Kilowatts. I'm going to have to change that because my equation doesn't work for kilowatts. And they gave me current. They told me that was, okay. I need to change that. I'll even write that down. I need to change that to watts. How do I go from kilowatts or kilo anything to just the base unit? Yeah. Times by 1,000. 6.4 times 1,000, I think is going to be, what, 6,400? Is that right? Okay. I'm looking for an equation that has the V by itself and has power and current in it, and I think that one is this, yes? Power over current. It's going to be 64,000 divided by 32. Do that one in your head. Well, 64 divided by 32 is 200 volts. Is that right? Yeah. By the way, your standard plugs offer 120 volts. This stove would not work off of a standard plug. If you pull your stove away, you'll see it's got a big fat cable with a special plug. Your stove and your clothes dryer are usually the two that have special plugs. Number 4. You know, if I give you a part A, a part B, and a part C, I'll bet you want to go in order. In fact, Kiana, I've done enough tests to know I'll bet you I'll use the answer from part A to probably figure out part B, and I bet you I'll use the answer from part B to figure out part C. It's kind of how tests work. Yeah? Okay. Energy. Well, they gave me power. What's that 8? Time. Except what's the problem with that 8? What did we need time to be measured in for our equations to work? Seconds. That's why I bold fonted hours. Okay. Oh, and if I didn't tell you about 1/3 of these questions, I won't tell you which ones, I literally took right from the test and changed the numbers. In other words, if you ace this quiz, you'll find a big chunk of the written section of the test pretty familiar. Okay. How do I change hours to seconds? Yep. Times by 60? That would change it to minutes. How many seconds are in 1 hour? It's on your yellow sheet. I think on your yellow sheet I told you that 1 hour equals 3,600 seconds. Did I not? Yeah. Well, you could break it to 60 minutes in case you needed, because that's if they gave you the time in minutes or they wanted it in hours, or I don't know. So the time in seconds is going to be 8 times 3,600. 28,800. So energy is what? Power times time. It's going to be 1,200 times 28,800. And I get a big number, 3, 4, 5, 6, and 4 zeros. 3, 4, 5, 6, 1, 2, 3, 4 zeros. And energy is measured in joules. 34,560,000 joules. If you got that, 2 out of 2. Otherwise, I would give you 1 mark for that, half mark for that, half mark for that. Now, if you went 1,200 times 8, you forgot to change the 8 to seconds, which would give you 9,600. If you said this, I'll give you 1.5 out of 2. Okay. Is that okay, Jordan? Good. Then just convert your answer from A to kilowatt hours. Be wonderful. Oh, well, 1 kilowatt hour is 3,600,000 joules of energy. So if I want to convert this, it's going to be 3, 4, 5, 6, 1, 2, 3, 4 zeros divided by it's going to be 3, 4, 5, 6, 1, 2, 3, 4 divided by, I'm missing a zero? How many zeros? 5, Mr. Dueck. You get 9.6 kilowatt hours? That's what would appear on your bill. Because, Leah, having a bill for 34,560,000 would terrify people. And in fact, that's one computer. Think about all the electronic devices. And that's for 8 hours. Think about a bill for an entire month. You use many millions, perhaps hundreds of millions, perhaps some of you billions of joules of energy a month. It's too big. Joule is too small. So we convert it to kilowatt hours. I guess 1 mark for that, 1 mark for that. But if you got the right answer, again, 2 out of 2. If BC Hydro charges 8 cents per kilowatt hour, how much does it cost? Oh, look at that. Cost equals the kilowatt hours times the rate. The kilowatt hours, 9.6 times 0.08. You know how much it costs? Not enough. It costs 77 cents. Right? And the reason is, Matteo, we're too good at producing electricity here in BC. We have hydroelectric power. We have cheap electricity. So again, why do I tell you to turn lights off? Why do we tell you to save energy? Is it for the money? Not really. It's for the environment, because we don't want to have to build more dams. They do damage the infrastructure of our salmon runs and things like that. 77 cents. I would give you 1 mark if I saw that. Half mark for the answer, half mark for the number. Half mark for the numbers, half mark for the answer. But if you got the right answer, 2 out of 2. Number 5. V equals question mark. Well, they told me the current was 4. They told me the power was 60. They also told me time, but I don't think I need it, because I think I can go V equals power divided by current. I'm pretty sure that's on my formula sheet somewhere. It's going to be 60 divided by 4, 15 volts. 1 mark, half mark, half mark. B wants me to find the resistance. Okay. R equals V over I. It's going to be 15 divided by 4. I have to use an answer from part A to find part B. 15 divided by 4, 3.75 ohms. Again, 1 mark, half mark, half mark. How much energy? Well, energy is power times time. The power, they told me it was 60 watts. Now, they changed the time here. In part A, it was 40 minutes. Why did they give me that 40? I kid you not, Damien, I gave you that totally to confuse you, to give you one more number to worry about. But here in part C, the time is 20 minutes, but I need to change that to seconds. How do I go from minutes to seconds? How many seconds are in 1 minute? 6. So you know what? It's going to be 20 times 60. That's 1,200 seconds. So the energy is going to be 60 times 1,200. 72,000 joules. 1 mark for the equation, half mark for the number, half mark for the answer. Is there a part D? Nope. Number 6. Find the current. They gave me the voltage. They gave me the power. Current is going to be power divided by voltage. It's going to be 240 divided by 120. Oh, I can do this in my head. It's going to work out evenly. 2 amps, or 2.0 if you want to even put a decimal. 2 amps. 1 mark, half mark, half mark. The resistance. Okay. R equals question mark. Oh, R equals V over I. It's going to be 120 divided by 2. 60 ohms. Is that right? People nodding? 1 mark, half mark. Yo. Just an answer. 5C, yep. Figured it out? Yep. Good, I heard your brain click. I even heard the hamster start running on the wheel again. Squeak, 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 squeak. Heat energy. Heat what? Energy. Okay. Energy is power times time. Did they tell me how much power? You know what, Mr. Dueck? Use your DFIC approach. E equals question mark. Power equals 240, because power is measured in watt. Time equals 20 minutes, which is 1,000 times by 60, 1,200 seconds. So how much energy? 240 times 1,200. 240 times 1,200. And I get 288,000 joules of energy. 1 mark. Forgot to write the formula, Mr. Dueck. E equals PT. That gets you 1 mark. That gets you a half. That gets you a half. But again, if you got the right answer, 2 out of 2. Convert to kilowatt hours. Kilowatt hours is going to be 288,000 divided by wow, 0.08 kilowatt hours. 2 marks. Can you give yourself a lovely score on this quiz out of, what's it out of? 26? Can you make sure your name is on them? And then pass them inwards. So we're looking at the sheet called Practice Circuits. This is a very similar question to stuff I'm going to ask you on the test. I'll give you a circuit. There'll be a bunch of blanks, and it's going to be fill in every blank you can. Okay? I gave you some steps. You got your yellow formula sheet out. We're going to try and do this from memory. What did I say the first thing that you wanted to do was? It was find the battery and identify which way is downhill. Find the battery and identify. You know what? That's downhill. That's downhill. Which way is downhill in that middle branch? Upwards. That's downhill. Number 2. Is that okay so far? Then I said, if you can find the total current, the question's going to fall apart. Have they told me the total current? So what I'm really looking for is, did they tell me the current coming off of the chairlift, off of the battery anywhere? Nope. Here we split up, so I'm not going to worry about that. Did they tell me the total current here? No, but I always check for that next. Did they tell me the total current? No, they did not, but Damien and I looked. Then the third thing I said was, look for any resistor where they told you 2 things. Is there a resistor where they gave me 2 pieces of information? Yeah? Yeah. Then that's where I'm going to attack this, because if I know 2, I know 4 things. This resistor right here, they gave me resistance, and they gave me current. Okay? How the heck can I find, sorry, they gave me watt power, not current, wattage, power. How can I find the other ones from this? This is an advanced one. I'm sneaking in here. What's the equation that has power and resistance in it? You guys have one. What's the equation on your yellow sheet that has power? The yellow sheet that you all have in front of you. The yellow sheet that you all have in front of you. preferably not face down. I know, kind of want you looking at. Looking for an equation that's got power and resistance in it. I want to find this. Now, I haven't done this one with you, but we can add this to our formula sheet if you want. How could I get the current by itself? Because that's what we want to find. How would I move this r over? What's this r doing to the I squared mathematically? Adding, multiplying? So you know how I'd move it over to the other side? What's the opposite of timesing by r?
Dividing by r.
Another equation would be this. Another equation would be this. What am I trying to find here? Trying to find current if I can. I've got the I. Have I got the I by itself? I got a squared. How do I get rid of a squared? What's the opposite of squaring something? Nope. This is an advanced one. This is why we're going to add it to the formula sheet. You're right. If I heard you right, I'm not sure. Say it loudly. Square rooting.
Yeah.
Yep. If you want to get rid of a squared, so on your yellow sheet, in the second box where I have all the power equations, if you want to, you can also add so on your yellow sheet, right here, in the second box, there's a little gap right there. I left it there for a reason. If you want to, you can add that equation. Apparently, I equals the square root of P divided by R. Hey. Right there. Oh, you want the actual how we got there? Okay. We started out with the one from your formula sheet, I squared R, which is on there. And I said, well, how would I get the R by itself? Divide by, or so how would I get the I by itself? Divide by R, square root. So that's the one that this is the one you're going to put on your formula sheet. This one. So, what's the power in that resistor? How many watts? Yeah, I said.
9.2.
So on your calculator, go 9.2 divided by, what's the resistance? What's the resistance there? 33. Hit equals, and then square root that. I'm going to go square root answer button. Even a crappy calculator has a square root button. Dan, your cheap one has a square root button on it still, right? They all come with that. And I get the current here is 0.528. I'm going to write that in, 0.528 amps. How's that help? Riley, what did I just find here? What's this? What's this? In ohms, what I measure in ohms. Resistance. Oh, you know what? I also have V equals I times R. I can find the voltage that I lost going through there. So I'm going to go 0.528 times 33. You know how many volts? 17.4. Now we're cruising. 17.4. You okay with how we got there? This is a tough one. Is that okay? Yeah? Let's go skiing, Lena. Starting here. How high are we starting? How many volts high? Nice and loud. Nice and loud. 24 volts. What do I lose going down this hill? How many volts? Then I go through this resistor, this hill. Do I end up at the bottom? Did I end up at the bottom of the chairlift? Say yes. Did I end up at the bottom of the chairlift? Yeah. So here's what that means. If I start 24 volts high and I lose 17.4 going through that first resistor, how high must that second resistor be? How many volts must it be? How many volts must it be? Got to be 6.6. Has to be. This has to be 6.6 volts. Why does that help? I now know two things there. How can I find the current if I know the voltage and the resistance? Coming up closer? Yeah. How can I find the current? Yep. They're not very big. How can I find the current? Look at your yellow sheet. How can I find the current? What's the equation, folks? I equals what? What's V? What's V? What's V here as a number?
6.6.
What's R? For Pete's sake, do that on your calculator. What's the current? What's the current? What's the current? What's the current? Folks, I'm getting annoyed. Someone call it out. What's the current? Kyle, what? 0.66 amps. Excellent. Okay, we went V over R. Why does that? Oh, what's the power? How can I find power? From your yellow sheet. V times I. What's V? 6.6. I just found I. 0.66. Excellent. So 6.6 times 0.66. How many watts? 4.356. All righty. Now we're cooking. You with me? Okay. Ready, my friend? We're going to go skiing. Ready, Mateo?
No.
How high? 24 volts. Ski with me, ski with me, ski with me. I'm always going downhill. How high is that? Don't know. How high is this hill? How many volts? So how many volts must this be? If I start with 24 volts and the second hill is 6.6 volts and I ended up back at the bottom.
18.4. 17.4. Oops. Everyone.
Yeah, that's why I'm telling you to use a calculator. Okay, 17.4? 17.4?
Yeah.
Yep. Do I know two things here? Okay, there's got to be something else I can figure out. And there is. This right here is the total current. How many amps? Because, look, this ski run here, this resistor, this chunk of wire, Rihanna. Folks, I need your attention here. I see people looking around everywhere. Let's get up here, okay? This wire, no, get up here means get up here and look up here. This wire flows through the battery. It carries all the current. What's the total current going through this circuit? 0.66. How many amps right here? 0.66. How many amps right here?
4.66.
How many amps right here? 6.6. Now we split up. How many amps went this way? So how many amps went this way? How can I figure it out? 0.66. Take away 0.528. And it must be, okay? And we're doing circuits that are tough enough that I didn't bother trying to make them work out evenly. Why is that so nice? How many things do I know now? 2, I know 4. Find the resistance, find the power. Do it. Use your yellow formula sheet, use your calculator, fill in the blanks. You need to go, do this. I see far too many of you just sitting here. Do this. Yeah, I'm getting grumpy because people are like, I don't know how to do this because you're not trying it. R equals, what does R equal as a formula? V over I, so it's going to be 17.4 divided by 0.132. Wow, 131.8? Is that right?
So R equals
Usually I go to 1 decimal place, maybe 2.
Can we do like 8, 1, and then have like a little?
Yep, I'd totally take that. How about the power? Well, power equals V times I. 17.4 times 0.132. 2.2968, I'm going to call that 2.3. It's on your yellow formula sheet. You shouldn't need to ask. Look at your formula sheet, right? I don't mind answering, but before you ask, I'm really trying to teach your eyes to look in the right place here. I'm getting a little concerned. Your test isn't that far away, and I think some people don't know how to do any of this because they haven't been following along. Let's try number 1. So turn back. So anyways, I got, 0.132, 131.8, 17.4, 2.3. Let's try number 1. What does number 1 want me to find? Power. Which one? Power where? In R4, in resistor 4. Yes? Okay. First thing, I labeled downhill. That's downhill. I guess the current splits up right here. Goes this way. Meets up again. Is that okay? Yeah. Second thing, did they tell me the total current? Look at this whole circuit. Is there anywhere where you know all of the current, all the skiers, had to go through that chunk of wire and they told you the number? Ah, right there. Okay. How many amps right here? 2.985. How many amps right here? 2.985. Now it splits up, I'm not sure, but when they join back together, how many amps right here? And here's the important thing. How many amps right here? How about this next resistor? How many amps in R1? How many we're back. Why is that so nice? Well, I said the next thing you looked for is anywhere they told you 2 things. Is there anywhere I know 2 things? There is now. What's the voltage in that bottom, in R2? How many volts do you lose? Can you crunch it, please? No guessing. There's a formula. I'm telling you, it's not 10. How do I find voltage if I know current and resistance? How do I find voltage if I know current and resistance? Got your yellow sheet? Look at your yellow sheet. How do I find voltage if I know current and resistance? I times R. So on your calculator, 2.985 times 10. Do you get 29.85? Is that right? Yep. Keep skiing. Is there another resistor where I know 2 things? Yeah? What? That top one. How many volts do I lose going through this top one? How do you know? It does not say 12. It says R1 is 12 ohms. Sorry. I'm sounding intense. I got a cold right now. I got right now is angry voice. I apologize. It's not. It's 12 ohms. That's the resistance. How can I find the voltage? V equals I times R. On your calculators right now, go I times R. It's not going to work out evenly, and I can't do this in my head. It's going to be 2.985 times 12. Right? Right? It's going to be 35.82. Is there anywhere else where I know 2 things? Nope. Okay. Then the next thing I said, go skiing. Go skiing. Go in a complete loop. So you ready? Damien, we're going to start here. How high are we right here, kiddo? What's the voltage? Just read it. 80. Right? 80 volts. Ready? Okay. Look up. I'm always going downhill. I'm always going downhill. Oh, we came to a fork. Do you want to go through the top one or the bottom one? You know what? Since they want us to find something in the bottom, let's go through the bottom one. Okay? Yump. Do I know how many volts that hill is? No. Keep going. Do I know how many volts this hill is? Yeah? Do I know how many volts this hill is? Well, if there's only one hill that I don't know, I can figure out what it has to be. How high was the battery, the chairlift? What did you say we started out at? No, what did we start out at? 80 volts. Minus, how high is hill number R2? 29.85. Minus, how high is R1? Do you know how high this has to be? How high does it? How many volts does it have to be? How high does it have to be, folks?
14.
Got to be 14.33. Okay. Let me erase this. This R4 has to be 14.33. Why does that help me? What else can I now find? I heard someone say it. Current. Okay, find the current, please. How do I find the current if I know the voltage and the resistance? What equation will I use? I equals what? V over R. It's going to be 14.33 divided by 8. What's the current? 1.79. How does that help? What did this question want me to find? What did this question want me to find? In where? Where? Oh, you know what? I can tell you the power here now because I know the voltage and I know the current. I think I got an equation that has voltage and current and power in it. How? Got your yellow sheet available there, Kiana, so you can see it, right? Or someone on your table? By the way, if you're doing this and you haven't got your yellow sheet out, no wonder you're confused because we're finding this is all on the sheet. What's the equation that has power and V and I and has the P by itself? V times I. So what's the V? 14.33. What's the I? We just figured it out. 1.79. How many watts? 25.65. I'll even put a box around it because I'm proud that I found it. Let's try a couple more. Number 3. Oh, fill in the blanks on everything. Okay. First thing, labeled downhill. Downhill is that way, right? Always from positive to negative. That way. That way. I guess right here, some current goes this way, some current goes that way. This way. Is that okay, Riley? Second thing, did they tell me the total current? Is there anywhere in this circuit where they gave me a current in amps and I know everything had to go through there because there's no junctions? Oh, at the top? Right there. Total current is 0.2. So how many amps right here? 0.2. How many amps right here? 0.2. How many amps right here? 0.2. How many? 0.2. How many amps right here? 0.2. How many amps right here? 0.2. How many amps went this way? 0.1. So how many amps went this way? There you go. Please don't say nonsense answers. Okay. Oh, how How many amps down in this bottom one? Well, here's 0.1, here's 0.1. They flow back together. How many amps right down here? 0.2. How many amps through this bottom resistor? 0.2. Ding, 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 ding. I now have two things. So I can solve for those. And up here I have three things. So let's fill in those blanks and we'll tackle the other ones. What's the voltage up here? How can I find the voltage? I times R. So I times R. Can you do that on your calculator or in your head? Because it's your 10 times table. You might be able to do it in your head. How many volts do we lose going through this resistor? 2. See how we got that? Aiden, you follow how we got that? Yeah? I times R? Yep, okay. By the way, Rihanna, how high is the chairlift? How many did we lose going through here? Leaving. I got 10 more volts that I got to bleed through this circuit if I keep skiing. I'll just kind of keep that in mind. Let's do this bottom one because I know two things. I can find the voltage. How many volts do I lose going through here? I times R. Can you do the math? Please, without guessing. I want you to do the math. I said you could do this top one in your head because it's a 10 times table. What I don't want is just guessing wrong. 3. Thank you. 3 volts. Oh, by the way, how many watts of power? That bottom one. Crunch the numbers. 0.6. How'd you get that? V times I. Power is measured in watts. Okay. Do I know two things in either of the other remaining resistors? Nope, so we're going to have to go skiing. We're going to have to go skiing. Ready, Nate? Let's go skiing. Nate, how high are we when we leave the chairlift? 12 volts. What do we lose going through here? Leaving? 10. Do you want to go left or right? Doesn't matter. Pick. Right? Do you know how high this hill is? I don't. Keep skiing, keep skiing, keep skiing. How high is this hill? How many volts? And we got to the bottom. So if we start 12 and we lose 2 and we lose 3, how many volts must this hill be? Got to be 7. Do I know two things there? Well, then I know all the rest. What's the resistance in this hill? How do I find resistance if I know voltage and current? R equals what? V over I. So it's going to be 7 divided by 0.1, which is what? 70? And that's ohms. And I know the power. How? Power equals what? Times what? V times I? 0.7, is that right?
Oh no, I'm talking about
So 7 divided by 0.1? I think it's 70. Try it. Dividing by 0.1, same as timesing by 10. Okay? Now, I'm going to show you a shortcut. Look up. See right here? The current, the skiers, were able to split up. Some went this way, some went that way. And they met up there. Going this way, how high was this hill? How many volts? 7 volts. The only way that they could go this way and meet up, if you were skiing in real life and you split up and some people went on the left-hand trail and some people went on the right-hand trail, the only way you could meet up again is if you skied down the same height hill. Has to be. Think about it. If you shake hands and meet up, you left at the same height, you meet at the same height, you must have gone through the same drop. Now, the other way, Riley, you can get it, you can actually draw the circuit. If you ski this one, that path there, you'll find the mystery voltage has to be 7 volts. Why does that help? Because I now know two things. What's the resistance there? Also 70 ohms. In fact, you know what? These two resistors are identical. I think they both have the same current and the same voltage and the same wattage because they have the same resistance. I'm going to do one more and I'm going to shut up. Dueck? Yep.
So does that mean if there's like another one of these?
Another one of these.
And they separate and they meet back together?
Ah, Riley, what? This is good. Yes, keep going.
And then these, if you find these ones on this side, on the right side, that means you know the left.
Only the voltages. The reason these were all the same is by a fluke. The resistances also happen to be the same, but look up. I'm going to muck up a diagram. This is wrong. Well, so look here. Are these two resistors the same? Then they're going to have identical currents and identical voltage drops. Let me find one where the resistors... Here's one where the resistors are not the same. I'm telling you, if we lose 8 volts going through the top hill, we have to lose 8 volts going through the bottom hill because that's the only way that we can split up and meet up. That's a shortcut that you can use for what we call a parallel circuit, where you have two resistors that are side by side. Fancy word, parallel. If, for example, I looked here, these two voltage drops will be the same. Currents will be different, resistances are different, power will be different, but they're going to be the same height, same voltage drop. That's an advanced shortcut. Good call, good catch. Hey, let's do number 4, okay. Number 4, as a little twist, is asking us to find the battery, how high the mountain, how high the chairlift is. Okay. We start out by asking, is there anywhere where they told me the total current? Now, they did tell me the current right here. Is that the total current? No, because there's another path. Okay. Oh, but wait. Do I know 2 things? Well, then I know 4. And the one I'm always interested in finding is the voltage. How many volts going through there? What do you get? How do you find it? I don't know. How do you get it? I times R, so it's going to be 1.5 times 40. Is that 60? Okay. And now we can use Riley's theorem. We'll name that. We're going to call that Riley's theorem for the rest of the year. Riley said, Mr. Dueck, if you ever have a spot where things split up going that way, and they meet up, this hill and this hill have to be the same height, same voltage. So how many volts do you lose going through this resistor? Also 60. That's Riley's conjecture. Why is that so nice? Because now I know 2 things. How many amps are going through this resistor? How can I figure that out? Do I know power? Find a different one that has I by itself. Earlier box. I think, isn't it V divided by R? 60 divided by 10? How many amps? 6. 6. Right? V divided by R? So you ready? Look up, look up, look up, look up, look up, look up, look up. How many amps going through here? How many amps going through here? 6. How many amps going through here? Okay, without yawning. Ready? How many amps going through here? No, this is important. 6. How many amps going through here? 1.5. How many amps meet up together right there? What? Say it loud. Gotta be. That's why I drew the directions of which way was downhill so I could figure out how they meet up. You know what else that means, Jordan? I know 2 things down at the bottom. What's the voltage? How many volts do we lose going through that resistor? Is it 30? I times R. I still don't know the chairlift, but how many amps right here? Right here. You know this. How many amps? How many amps right here? How many amps right here? How many amps right here? How many amps in here? With authority, 7.5, because there's nowhere else for the skiers to go. Amps don't vanish. So they can split up and rejoin, but they don't vanish. 6, Mr. Dueck, 7.5. Why is that so nice? How many volts do we lose going through that resistor? How many volts do we lose going through that resistor? Because I know 2 now, I know 3 or 4. Can you calculate it, please? It's going to be I times R. It's going to be 7.5 times 6. 45? All right. How high does the chairlift have to be for this to work? You ready? Start skiing. I don't know how high the chairlift is, but how much do we lose in the first hill? How many volts? 45? Do you want to go down the right-hand one or the left-hand one now? Doesn't matter.
Right hand.
Okay, let's go all the way on the outside. How many volts do we lose through there?
60.
How many volts do we lose through here?
30.
How high does the chairlift have to be if you can ski and lose 45, 60, and 30? Mateo, what? 135, is he right? It's gotta be. If you wanted to set up this circuit, you would need 135 volts. Now, somebody said, Mr. Dueck, I want to ski down the left-hand hill. That would also work, because if you skied here, you'd lose 45, 60, and 30. That also works to give you 135. So these are some of what you can do. For now, because I've talked a lot, if you look at the handout that I gave you last class called Solving Circuits Homework, which most of are easier than what I just threw at you, you can start working on this. Next class, we're going to practice some more. We'll try doing 5, 6, 7, 8, and 9. And I'll have a quiz of some practice circuits for you to solve. We're going to mark that on Tuesday. Your test is Thursday. You guys got a nice 4-day long weekend. I'm going to try and give you time on Thursday to get the take-home quiz done in class so you end up with no homework for the long weekend, I hope. Okay? So this handout here, I gave this out like a while ago, called Solving Circuits Homework. This is what you're working on. Again, if I sounded mad, I'm not. Right now I got